Hi Chemistry Scholars, at this point you should have completed the bell work, the Bare Essentials reading and questions, and now we are on to the types of bonding notes. Just a reminder that you have a mastery quiz next class on Thursday regarding 5.2 molecular geometry. Of course, you will be given a periodic table and a chart with the molecular geometry shapes on that for you. And then please also make sure that you complete the IP Thinking Electronegativity on TeacherMade. If there are any problems with Google Classroom, please make sure to email me. At this point, you should have out the polarity notes that you should have picked up at the door. If you are absent or for some reason you didn't get those, try to get another copy in class. But if not, if you don't have those, then you can take the notes on Google Classroom for now, and then when we're in class, you can get a hard copy of the notes and transfer them there. The front of the packet should look like this. We have an electronegativity scale and a bonding continuum. These are two resources that will be given on every test or quiz. You'll also want to have these handy when you're completing homework assignments or bell work. Bonds. So you should have just completed the reading that had kind of introduced the idea of polar bonds before with the polar bears. Where have you seen the word polar before? What do you think the word polar means? Pause the video and write something down. Think back to our trends on the periodic table that we talked about at the end of first semester. What is electronegativity? Hopefully you wrote down something like this definition: the ability of an atom of an element to attract electrons when the atom is in a compound. What's the trend? Look back at a periodic table. Well, it increases going to the right and up. Today, we're going to be using this electronegativity scale to calculate the change in electronegativity. So we see that electronegativity is greatest in this top right corner with fluorine, and then the smallest amount of electronegativity is in the bottom left corner near francium. Draw the bonding continuum from ionic to covalent below. So pause the video and you'll want to copy this bonding continuum down. Notice we have nonpolar bonds that have the least amount of change in electronegativity, but then great electronegativity difference becomes ionic. And we'll look at calculating those in just a minute. Once this is drawn, continue on with the video. On the continuum you drew above, what happens to the electrons at each end? Which end of the continuum do electrons get transferred from one element to the other? On which end are they shared? Well, if we remember the definition of ionic versus covalent, we would remember that on the right side where it says ionic, electrons in an element are being transferred, versus covalent bonds, we see the electrons are being shared. Write that down. For this number 4, the second number 4, you see it says a polar covalent bond is a bond in which the electrons are still being shared, but they're being shared unequally. In the cartoon that you read earlier, Bare Essentials, you should have seen this unequal sharing of ice cream. One of the elements in the bond is slightly more electronegative than the other. We'll see some examples of that in a minute. Well, you will need to do lots of determining if a bond is nonpolar covalent, polar covalent, or ionic. How do we determine if a bond is polar? We'll follow these steps here. First, we need to determine the difference in electronegativity of the elements. We'll use the electronegativity chart that is on the first page of this packet. Next, we'll look at the bonding continuum that we also see on the first page. We'll see where the difference falls, and then label it accordingly. Is it ionic, polar covalent, or nonpolar covalent? If it's polar, we can say it is a dipole, or it has a dipole. You can kind of think of those as synonyms. If the bond is polar covalent, the more electro element will have a slightly more negative charge. More electronegative, slightly negative, because that really means the electrons are closer to it. We therefore can label the more electronegative atom with a S-. It's kind of like a Cursive S, I think we've seen that symbol before. And that symbol means has a partially negative charge. Remember, it's not fully negative because the electrons have not transferred entirely. It's just partially negative while sharing. It's more negative than the other while sharing those electrons together. Then the other end would have a slightly positive charge in relation, so we put in little cursive S+. One useful thing to remember is N, O, and F are highly electronegative and will form polar bonds when bonded with C or H. You'll start to see this trend. So we may need to determine, for example, is NAF ionic, polar covalent, or polar? If we follow those steps, the first step we're going to take is look at our electronegativity chart here, find Na. We find that it has a 0.93 electronegativity, and then F has an electronegativity of 3.98. 3.98 minus 0.93, or me finding the difference, is 3.05. Next, I look at this bonding continuum and see 3.05 lands right in the ionic range. Therefore, it has an ionic bond. And the electrons will be fully transferred, forming two ions, Na plus and F minus. You have a few practice questions on the next sheet of your packet. Please complete those before next class. You can complete those right now. If you finish these notes, you have already finished the reading and the bell work. Then you can use the rest of the time after these practice questions working on your homework and then studying for the quiz that is next class. If you have any questions, ask a friend or send me an email, and I'll look forward to seeing you next class.